Hello everybody, welcome back to From Rhythm to Algorithm. I'm your host Brad. Today we'll be continuing our derivation and discussion of physical topics, trying to get to our ultimate goal of solving or resolving the definition of the word sensorality, proving an axiom. If you're new to this channel or to this series, again, this is part 86, so there's a bunch of ideas. But go watch those, but we're going to be picking up right where we left off in the last video. If you have not seen the other videos, you're welcome to watch this one. You're certainly going to be able to follow along or pick up some intuition, but we're discussing a lot of things kind of at the frontier of fundamental physics, mathematics, logic, and linguistics specifically, and then other subjects as well. But this one focusing really on the foundations of what people would call science, technology, not really engineering, and mathematics specifically. So last episode we discussed electricity, and we got a bunch of physics things, kind of hodgepodge of leftover things from last episodes. So our topics today will be talking more about momentum amplification, which we talked about last episode and introduced, more about the electron. We will be setting more physical foundations for discussion of the Navier-Stokes equation, which has been directly addressed and proven in my formal thesis, which I'll be going over again in future episodes. We'll be talking about some more historical developments along with the diction used to describe their intuition, just kind of reviewing their intuitions just to refresh and talk about all of the major jumps. So we'll be talking about Archimedes' principle and Archimedes a little bit, acceleration in the vacuum, states of matter, infinity, both physically and mathematically. Have a bunch of good things to go over in mathematics. We'll be doing new mathematics. Again, some of this might be broken up into different episodes. Again, I do a session of derivation. I literally write down a bunch of theorems, a bunch of dichotomistic pairs. If you don't know what those are, go watch my previous episodes. I explain what they are. But then I do a session of that, and then I formulate all of that logic into a nice little episode that I can put up on YouTube. Because again, all of this stuff, literally the entirety of this proof, I've proven speciality. The entirety of the proof is trivial to me, so I don't have to write any of it down. This is purely for education and financials. I want to make money off my discovery. So, getting going. Again, we discussed the big idea that the electron is asymptotic, meaning when two electrons come close to each other, they can't actually touch because they would need effectively approaching an infinite energy scale to get enough power, enough force to drive them close enough to touch each other, which is impossible. So we need to remind ourselves that the electron is not a point particle. It has some sort of internal structure. That structure is fractal. It scales as a fractal like everything else from big to small. That is something we've intuitively discussed that has gone away. Go look at a picture of the atom, go look at a picture of a black hole. They literally look the same, they scale the same in the same way. If you take a camera out of focus, turn it into focus, you see the discrete polygon levels coming into focus to a continuous irregular object. So we need to remember that it's not a point particle. What they say in fundamental physics right now today, that the electron has spin, but it is a point particle, logically impossible, physically impossible. It has some internal structure that we cannot probe, and it's irrelevant because it normalizes, right? In the same way it was fine to use parallax way back in the day. It's fine to approximate galaxies as point particles at certain distances. It's fine to say the electron behaves as a point particle. Again, it doesn't invalidate anything from previous in history, but again, back to general relativity and the standard model not being consistent and not being comprehensive, and at this point in this derivation, hilariously archaic. The appearance of that conundrum, of that contradiction, is showing you that the fundamental intuition used to articulate those theories were incorrect or incomplete, more precisely. So it's not a point particle. It has spin in the same way anything else spins. But they'll just, right now today, they call it a property, but it's really just a physical phenomenon, like you spinning around like this. Whee! We discussed the Pauli exclusion principle, that alternating, and then you can draw that, take that logic, and that has some sort of direct mapping to completeness on a guitar, right? If you're playing an alternating arpeggio, let's say I would just be way better, and I've demonstrated it with my guitar on one of my other educational series, but alternating picking, you can do a direct logical demonstration with alternating picking to have a continuous cycle where you're playing the same melody continuously, and it's preserved because you're using alternating picking. In the same way, an electron fills an orbital level with alternating spins. So momentum amplification. Again, we just talked about transistors, but more so because we have motion, and then our generality, motionality, just put ality at the end of motion. Then we have emotion, emotionality. So how can we use, there should be some direct logical mappings of momentum with emotion. And what do you know? There are. So again, think about fans cheering on a basketball team. It's the March Madness, it's the Final Four, they're going down to advance to the championship, and they're up by 10, and the announcer's like, they got all the momentum with them. Right? That's emotional momentum. That's momentum amplification. All of the people cheering you on. What else? But now imagine you're that basketball team. You're up. You have the momentum. You're winning, and then the other team comes back or sinks a full court shot and beats you, and you lose, and it's a buzz kill. It kills the momentum, right? Or it's good vibes only, and it's a buzz kill. These are all empirical bits of evidence showing that emotion has direct logical correlation, or direct logical mapping to emotion and momentum right now in our expressive sentiment right now today. And so, right, calling someone a buzzkill, good vibes only. How about a brainstorming session? Right, you're all sitting there, you're trying to think of a project or put together a dissertation or try to put together a grant proposal, and then someone comes up with a good idea, and then now we can ask the question, what's a good idea, right? It borders the logic to accomplish the goal. That's sort of novel. That doesn't, you can be in the answer all of these different types of questions. But point being is, if you're in a brainstorming session and someone has a good idea and that sets off a light bulb in another person's idea, literally the words you're articulating is causing people to make logical connections, which is what we've articulated here as words being tension points in conversations. And then you're building on that. You're building on one another. You're getting something together. So now you're excited. You're building off each other's energy. You're building momentum. And so rolling a snowball, and that's physically momentum amplification. Like literally, that's not an analogy or metaphor. Literally, the cartoon imagery of you throw a little snowball and it builds and builds and builds. That's momentum amplification, presented directly, meaning someone thought of, had that intuition, and then made this snowball momentum analogy. The electric potentials are systems under tension, seeking equilibrium with the least resistance. So again, we're introducing a new kind of concept that's not new, the path of least resistance. We discussed how we can bottle up all of the words like lag and latency and friction and anything that means to dissipate or remove efficiency from the change of a system state. We can call that dampening, but they're all any system's trying to reach equilibrium. In our reference to electricity, you have capacitance. You have some capacitor over here storing electrons, and some capacitor over here storing more electrons. Negative, negative. This has more charge. It's going to push this one that way. And if it's if it's a two-particle system, this one's going to go away this way slower, than this one's going to go this way faster. And so the potentials are system under tension, just meaning if it's any system that's at a state of unstable equilibrium, like we talked about a ball on the top of a mountain, and you give it one perturbation and it falls down the mountain. If you just have to do one thing simple like that, and then it creates reactions, like if you twist a band, then you let it go, and then it untwists, it's seeking equilibrium. So any system out of equilibrium is under tension. In the same way you go to move your body, you tense your muscles. So that's there. Again, we covered the entire logical consolidation or condensation or condensing, more precisely, of resistance. We'll talk about Navier-Stokes probably after this one, but we need the existence and smoothness. We've proven the existence of all things that can be proven which really gets to Gödel's incompleteness theorems, which we'll talk about again, but I've already made it an episode that's very explicit and well spoken in it. But you can go watch that if you want to, but we will review it. But I just didn't, in the electricity episode, did not cover the tension, the relation of tension and equilibrium. Just anything that is displaced from equilibrium is under tension. Buoyancy in feathers and bowling balls. So Archimedes, again, just I want to review the logic. You have the buoyancy force, and so again, when you have all of these adjectives, the force of gravity, right? The force, prepositional phrase, of gravity, the force of electricity and magnetism, of the strong force, of the weak nuclear force. You're differentiating past where it's useful and where it's logically, again, already condensed or consolidated, or that's pretty much, I don't know, you could probably find another word or two. But the force of buoyancy, what is it? It is the density of the liquid that is being displaced times the volume of that liquid that has been displaced times the force of gravity. And so now, in a lot of equations, right, you have the speed of light, you have the gravitational constant, you have, again, you have a bunch of constants in fundamental physics. And I've generalized all of those fundamental constants in any equation into what's called the dynamic limit, which is the direct form and addresses the P versus NP problem. We'll talk about that in a separate video that it is in of itself. But again, I've proven results that are just profoundly more applicable. Those are just the big, they happen to be, I mean, the logic is directly related to what I've done, so that's why I'm addressing these problems. But again, when you have a problem in mathematics, specifically logic, it's your intuition and your experience that's misguiding you, not the equations or the statements you're looking at. But all of the hoopla around these equations are all because of speciality, of human beings' desire to be distinct and be the best mathematician, and they've put all of this arrogance and hype around them that if you just have genuine curiosity about the world around you, and then you say, hey, I solved the P versus NP problem in hilariously easy fashion. People are like, no way, dude, that's an easy problem. And then they kind of like twitch and like short circuit. It's like, if this person does have any progress on a given problem, then he's going to be a good mathematician, and he can't get in front of me. And I'm like, I will blow you out of the motherfucking water with this shit. Because I prove sets of proofs. And that's not even something that registers meaningful to anybody. But the things that I write down, and I write down more than you guys will ever get through logically, and it's just me writing down casually when I have nothing else to do. But we'll revisit Gödel's theorems, but we've already made a whole video on that. But there is some relation to the physics, more so again just the logical completeness of different systems. But back to the force of the buoyancy force, it's just you displace some liquid, how much you displace it, it pushes back. It's a system under tension. Any system with a buoyancy force is a system that is under tension. Acceleration in the vacuum, again, why? If a feather in a bowling ball of, you know, why would they, of the same, let's just say of the same mass, which one's going to fall faster? It's going to be, you know, which weighs heavier, a pound of pennies or a pound of feathers? Which falls faster, the bowling ball or the feather? And so what it just really highlights is, again, the resistance, any cumulative set of forces that are resistant to the motion of the body, of the bowling ball, of the feather, and the other forces acting upon those bodies. So the big difference is the size, the mass of the Earth is acting equally on both objects. It's just the surface area of the feather is wider, so it falls slower. Again, just reviewing, just so you guys have those intuitions in your head. But the same kind of buoyancy, again, we're not viewing the entirety of the energy mass content of R3 of the world you live in right now today is a continuous pressure gradient, because everything's connected, nothing is touching. But those are just things I want. But now let's review the states of matter. Right, matter is to mass something that is fermionic, is what they would say in particle physics. But again, we've discussed why you can't model force as a boson, and boson doesn't even make sense. The thing that you really need to understand is mass occupies space. we're unique, things exist, and so this notebook is not my hand. It's really there's no analogy or metaphor. It seems stupid, simple, but it's true. This is an independent system. It can move independent of me, even though we're still connected. And so, but the states of matter, and so we've discussed a lot about what makes shape, what makes form, how that form came about because of mass condensing, or light condensing into mass, and that creating the environment, going from viewing gravity as a force in Newton to viewing gravity as the shape of the environment, from Einstein to viewing mass as the environment. It is the environment. And so we have, right, typically you're given solid, liquid, and gas. If you're exposed to particle physics or a tertiary school level of physics or research at all, you'll get plasma. You might get some cork, gluon, other stuff, just some exotic things that are just iterations. They're nothing unique. But right, you have a solid, you have something that's a definite shape and size, or definite shape and volume. You have a liquid, which is definite, that fit the container's definite shape, or definite volume, that fits to the container's shape. So definite volume, not a definite shape. And you have a gas, which is neither definite shape or volume. You have plasma, which is gas heated until ionization. And then you have what's called the Bose-Einstein condensates, which are extremely cooled boson gas, acts as a singular particle. And that's where I just have mass occupies space. Fundamentally, it makes no physical sense to say bosons. Defining a boson as something with a spin hole, okay, great, fantastic. But saying that bosons can occupy the same quantum state at the same time is no. And again, quantum meaning discrete, not small. But everyone seems to think that just means small. So I don't know why everyone's so fucking stupid. Sorry, try not to swear that much. Not really, I say whatever I want. But condensates, so again, obviously there's some phenomenon, but when it gets cooled extremely low, it just behaves as a singular particle, as a singular unit. The electrons are not occupying the same physical space. That's not possible. Can they have the same properties at extremely low space? Probably, because that's what leads to superconductance and zero resistance. So my guess is it's just eliminating the resistance. That when it behaves as a singular particle, it's eliminating the resistance, but it's not occupying the same space. Once again, you probably just I'm certain you have a measurability limit there. You just can't measure the space that's there, because it is logically and physically impossible to have two bits of mass at any size to occupy the same thing, because it's not, matter's not in space. Matter creates space. Like, I don't know how many times I have to say the same shit. Okie dokie. So, anything else for pure physics that I wanted to cover? Let me make sure I am still rolling.